Ever wonder how AI sees the world? Not just recognizing a cat or a car, but understanding every pixel in an image. What's a table? What's a chair? How do they all fit together? That's semantic segmentation, the backbone of self-driving cars, medical imaging, and more. But here's the catch. When the world gets complicated, when new objects appear that the model has never seen, traditional AI struggles. This is the open vocabulary problem. Imagine training a model to recognize dogs and cats, then asking it to identify a squirrel or a kangaroo. Traditional methods freeze up. They're stuck with a fixed list of labels. But what if we could teach AI to handle any object, even ones it's never encountered? That's the goal of open vocabulary semantic segmentation. The challenge: most existing methods rely on weak supervision, using text descriptions instead of pixel-perfect labels. But here's the glitch: they often get confused. Think of it like learning a language through fragmented sentences. You might guess the meaning, but you'll mix up words. These models struggle to tell the difference between similar objects, or understand how categories relate. Enter SynSeg, a breakthrough approach that tackles these issues head-on. It uses two key innovations: multi-category contrastive learning, MCCL, and a feature synergy structure, FSS. Let's break them down. First, MCCL. Imagine teaching a child to sort toys. Traditional methods focus only on same category items, grouping all cars together. But MCCL teaches the child to compare different toys too. It helps the model understand not just what an object is, but how it relates to others. For example, a cat isn't just a cat, it's also not a cabinet, even if they're in the same photo. This helps the model spot subtle differences, like telling a squirrel apart from a raccoon. Now the second part, FSS. Here's the problem. AI models often get distracted by the obvious stuff, like the main object in a photo, while ignoring the background. But the background can hold clues. FSS fixes this by combining text cues with image features, like a detective cross-referencing a suspect's description with a crime scene. It highlights what's important and dials down the noise, making the model more precise. The results: SynSeg crushes the competition. On standard tests, it's 4.5% better on one dataset, 8.9% on another, like a sprinter pulling ahead in a race. But why does it matter? Because this tech could power smarter robots, better medical diagnostics, or AI that adapts to new environments on the fly. So what's next? As AI learns to see the world with more flexibility and depth, the possibilities are endless. From helping doctors spot tumors to enabling robots to navigate crowded spaces, this is just the beginning. But SynSeg is part of a larger revolution. Think of models like CLIP and ViLT, which connect words with images by training on billions of image-text pairs. When you say a tree with green leaves, the model doesn't just guess, it knows what to look for. This breakthrough led to open vocabulary segmentation, where models can label objects based on any text prompt. Want to find a red bicycle in a rainy street? They'll do it, no rigid labels needed. Researchers are solving real-world puzzles too. SamClip combines vision and language models to answer two questions at once. What is in a picture, and where is it? Then there's training-free semantic segmentation, which skips months of training by using large language models like a dictionary, giving computers instant access to knowledge without the heavy lifting. The impact: massive. In self-driving cars, these systems spot pedestrians, road signs, and obstacles in real time. In medicine, they analyze descriptive reports to detect tumors or anomalies. It's like giving machines a lens to not just see, but understand the world through language. So next time you snap a photo or scroll through images online, remember, behind the scenes, AI is learning to think, interpret, and even imagine, blurring the line between human and machine perception. The future isn't just about seeing more, it's about understanding everything. Thanks for watching, stay curious, and let's keep exploring the future.